I'm going to do this. It's about 6 o'clock on Monday, so I'm going to do this one, and then I'm going to knock it off for tonight and finish the other 2 sections tomorrow. This is the electron cloud section. In any S sublevel, remember the S sublevel is the sunny room. So in any S sublevel, there could be 2 electrons because there was only 1 bed. In an F sublevel, the F is the fine room. So you had sunny room, had 1 bed. Pink room, let's go the other way. Pink room had 3 beds. The dark room, 5 beds. So the fine room has how many beds? 1, 3, 5. What comes next? 7 beds. So 7 times 2 is 14. If they're in the same orbital, remember how we've been drawing 1 arrow up, 1 arrow down, they have to have opposite spins. Here I wanted you to draw the orbital notation, that's why I put this down here. And oxygen has 8 electrons, so let's put them in. 1, 2, 3, 4, 5, 6, 7. Notice how I put them in one at a time before they pair up, then they pair up. 8. So now how many unpaired are there? 1, 2. What sublevels are in the second energy level? Well, here they are. Well, let's do it this way. The first energy level has an S. The second has an S and a P. The third has an S, a P, and a D. So how many is in the second energy level? Just this S and P. In any D sublevel, I did this up here, are 5 beds. So that's 5 orbitals. So the answer is B. When there's an option, will electrons pair up or they go in one at a time? Remember, we go in one at a time before they pair up. So the answer is B. How many electrons in the outer shell of carbon? Now, if you look at your periodic table, you'll find that carbon has a 6 on it right here. And then this is it's 12.011 on your periodic table. Or that means that there's more than one isotope of carbon, but the average is closest to 12. Because there's a lot more carbon-12 than there is in the other kind. But to find valence electrons, you need to write the configuration. So the 1s holds 2, and then the 2s holds 2, and then the 2p, how many do I have left? There's only 6 total, 2, 4. I just have 2 to go there. So now how many are in the valence shell? Valence is the outer shell. Outer means the highest coefficient. Okay, so what is the highest coefficient? There's a 2 there. There's a 2 there, so the highest coefficient's 2. How many electrons are there? 2 and 2 makes 4, so that's B. All right, the coefficient of the highest energy level in nitrogen. So nitrogen has 7 electrons. If you look on your periodic table, it'll say 7 for an atomic number. So 1s2, 2s2, 2p6. Oops, I just went crazy. Now I went to 10. So instead of 6 here, there should be only 3. So 1s2, 2s2, 2p3. That makes 7, doesn't it? So how many are in the highest energy level? Well, the highest energy level is the highest coefficient. So there's 2 here, 3 here. That makes 5. At the risk of messing up my video, I'm going to go back out here and look at something real quick. Let's go here to periodic table. Another way to find the number of electrons in the outer shell is simply count the columns. See, that's column 1, column 2, then column 3, column 4, column 5. Notice that nitrogen's in the 5th column, has 5 in its outer shell. Carbon's in the 4th column, it had 4 in its outer shell. Oxygen would have 6 in its outer shell, and so on. Okay, number 10, the subatomic particles that are transferred from one atom to another during the formation of some compounds. Well, that's electrons. That's what's on the outside. All right, let's flip back over to the periodic table to look at the blocks. Oops. So you have notice how this is 2 blocks wide? That's the S region. Notice how these all say D? 10 blocks wide, 10 electrons in a D sublevel, that's the D region. This is the P region, and this is the F region down here. So if you're looking at contains tin, you'll find tin right here. It's in the P block. And the next one is contains iron. Iron's right here. It's in the D block. And sodium is in the S block. You see it right here. And the last one is uranium, and uranium you'll find out here at the bottom in the F block. So let's put in the answers. The D block, that had iron in it, so that was B. The F block had uranium in it, and that was D. The S block contained sodium, that's C, and the P block had tin in it, that was A. Okay, the sequence. The easy way to do these is go back to your table. The sequence is 1s, 2s, 2p, 3s, 3p. Then it goes to 4s, and then 3d right here, then 4p right here, then 5s, then 4d, then 5p. I'm just going left to right across the table, then 6s. Oops. After 6s, oops, right here. And you get 6s. There's a little asterisk thing right here. That means go down here. So it goes 6s, then 4f, then you come back to 5d. Right there. Then you go to 6p. Then you go to 7s. Then this little double asterisk thing says go down to 5f. Then back up to 6d. And then 7p. So that's our filling order. So then you just look at the ones, see which ones match. So 1s, 2s, 3s doesn't work. Oops. 1s, 2s, 2p, 3s, 3p, 3d doesn't work because 4s should be over here. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, that's your right answer. Because that matches the sequence on the table. And I accidentally hit this over here, so we'll erase this real fast. There we go. All right, then the correct sequence here, this is further down the table. So if you do here, you got 4p, 4d. Well, that doesn't work because 5s would be in between. You got 4p, 5s, 4d. That's good so far. Then 5p, that's good, matches the table. Then 6s follows 5p, that matches. Then 4f, 5d, 6p. This is the correct answer. So that's B. This one here, 5s, 6s, doesn't work because you got lots of stuff in between those. This looks reasonable. 4p, 5s, 4d, 5p, 6s, and there, after 6s is 4f, so 4f should be over here. That's why that one's wrong. Okay, what's invalid? Was there a sunny room in the 7th energy level? Yeah. Pink room in the 3rd energy level? Yes. Dark room in the 2nd energy level? No, because the 2nd energy level only has S and P. So it's 2D, doesn't make any sense. And then orbitals are regions of space around the nucleus where a blank is likely to be located. They're regions where an electron is located. They're not paths because we don't know how they move in any particular direction. So it's just a place in space, like a three-dimensional space, where you'd find electrons. All right, now we're going to put the load 1 to 8. This, I have to think about this. So 2s. After 2s, 1s is first. That's not on here. Then 2s. And after 2s is 2p. Is 2p on here? No, I don't see it. After 2p comes 3s. That is on there. After 3s comes 3p. Not there. After 3p comes 4s. Not there. But after 4s comes 3d. That is there. Then 4p. Not there. Then 5s. That is there. Then after 5s is 4d, not there. After 4d is 5p, that is there. After 5p is 6s. 6s is not there, but 4f is, that's what comes next. After 4f is 5d and then 6p. Then 7s, 5f, and then 6d. So there's your sequence. And that's the end of that section of the test.